And start the recording on our PowerPoint for our straight cooling product today, our HMCG2. And at this time, team, I'm going to go ahead and share my screen. And I want to thank everyone today for joining us in our recording of this HMCG2 horizontal AC overview. So let me go ahead and get that pulled up for everyone. And as usual, I'm going to ask my team members to go ahead and kind of monitor it to make sure that we can see the screen. And if you, by all means, if you can't, please let me know. And so Emily, Dave, and Robin, can you see that screen right there?
Looks good, Joel.
Okay, well, fantastic. Well, let's, again, today we're going to be talking about the HMCG2 horizontal AC overview. And when you first take a look at this product, team, it looks just like the HMH7. However, it is a straight cooling product. So we want to stress that whenever we're talking about this. It is a straight cooling product. And because it is a straight cooling product, we're not going to have the necessary wires to go outside like we would the heat pump product. And we're going to find out here in a little bit. We're going to have literally just 3 wires going outside. So it's going to have full functionality with just 3 wires outside. And so as we take a look at it, there are some things we always like to talk a little bit about as far as minimum and maximum temperatures. We can see on the outdoor coil, minimum 50 degrees outside, which is pretty remarkable for a straight cooling unit, and 122 degree maximum outdoor temperature. And on the indoor coil, we can see that we've got a wet bulb cool temperature of 57 and 72 for minimum and maximum. So it's a very versatile product as far as, humidity control and being able to operate, through a very wide range of operating conditions. Another thing I'd like to talk a little bit about, the big news flash, it has enough factory charge for a 25-foot line set. So unlike much of our other Champion residential products where they're pre-charged with enough refrigerant for a 15-foot line set, the new HMCG2 horizontal unit has got enough factory charge for a 25-foot line set. So I think that's pretty cool that we enhance that a little bit, and it's going to help the contractor a little bit out there as far as not having to charge more refrigerant into it if he's got a pretty average line set of about 25 or 30 feet. So that's pretty cool.
Joel, that's interesting. So where does this line up in our Champion AC lineup?
As it turns out, Emily, you must have read my mind because that's our very next slide. So as we take a look at it, the lineup, as Emily was talking about or asking, it really kind of falls right in the middle from our AL21, our very, very high-end product, our straight cooling high-end product, and then our TCD2, our 13.4 SEER. So if you kind of take a look at the lineup, you see that it fits right square in the middle. And really, it's a direct replacement for our older legacy model, TC17, which was a 2-stage unit. But this unit is a fully modulating inverter drive with a simple conventional 24-volt wiring. So let me say that again, even though it's got simple conventional 24-volt wiring, the compressor itself inside this unit is a modulating inverter drive type of compressor that's going to modulate between 35 and 100% capacity. So like I said, just a lot more features. It's going to be a lot more comfortable. It's going to give you a lot of bang for the buck, in that replacement market, especially where we would have normally, or we would have in a legacy condition, put the TC17. Good question. Yeah.
And then I think I see some Energy Star ratings, but this one doesn't have Energy Star?
That's a really good question. As you take a look at the lineup, you're going to notice that we do have some Energy Star rated products, AL1921 and our TCF2, which is a 15.2 at SEER 2 rating. And the HMCG2, the reason they don't have currently an Energy Star rating on it is because of the way the inverter drive and the way they test it. And so as part of the testing process, it's a very, very efficient unit. As a matter of fact, you see it's 16 plus SEER. And in most applications, it's going to get quite a bit better than that. But you got to remember, because it's fully inverter drive and the way they handle the indoor airflow and the way they handle the inverter drive outside, they have to test it at 100%. And at 100%, in that little narrow window of 100% capacity and 100% airflow on the indoor unit, it does not make that Energy Star rating. That is correct. Good question. Any other good questions or comments?
But I think typically you say that most of the time it's not going to be at 100%. Most of the time it's going to be running at what is that 60%?
Yeah, and that's an excellent point. So, in the summertime when this thing is running and it's going to be, just on a typical design day, for instance, it's going to be cruising along between about that 70 to 80% capacity most of the time. And then, of course, when it gets real hot outside, it'll go ahead and modulate on up accordingly. But likewise, on those mild days where you would normally just shut a unit down, and of course, if the unit's not running, you're not going to be dehumidifying. So imagine an 82-degree day and it's raining in Florida. You're going to want that unit running to dehumidify the space. And it might be down to 60 or 65 or 70% capacity. And it's just kind of cruising along, very, very efficient, and still removing humidity instead of just cycling off. So that's the idea behind the inverter drive in general, is it gives you a lot more comfort and a lot better humidity control because it has enhanced runtime. So yeah, good question. Good question.
That sounds great. And it looks like you've got a conventional, like you could just use a conventional stat. You don't even need a two-stage stat.
Yeah, and that was the one thing that was really remarkable about this product when we launched this product, was the fact that our customer base, they wanted something simple. They wanted inverter drive technology. They wanted to have the comfort of inverter drive, but they didn't want to mess around with communicating systems and some of the things that are associated with communicating systems. So this unit just uses a conventional 24-volt wiring, and you're actually going to wire it like it was a two-stage unit, but with just that simple two-stage wiring scheme, so to speak, you still have this inverter drive and you have this wonderful comfort. And so that was one of the things that we were really trying to target for kind of a sweet spot with this unit, is simplicity and comfort, and still have some really good inverter drive technology. So it's a really nice, and even though we kind of position it as a mid-tier product, we're seeing the unit applied in really more towards a top tier type of application because of its capabilities. Yeah. So good
Certainly.
question.
No,
Yeah.
that sounds great. And these are in whole tonnages.
Yes, that is correct. That's a good question. So 2, 3, 4, and 5 tonnage. They come in whole tonnages. That is correct.
Very good. I think you've got some slides to show how to wire this up. Is that right?
Yes, absolutely. So let's go ahead and jump on into that. We're going to kind of get into the weeds a little bit now. And so at this time, we're going to actually be discussing the low voltage wiring of this unit with a standard ECM type of motor. Now, remember that low voltage wiring, and what we're going to be looking at is going to be a simplified block wiring diagram. We're literally going to take it wire for wire. And one thing we kind of have to keep in perspective, or we want to remember, is that our air handlers, they're equipped with pigtail connections instead of a hard terminal like you'd see on a furnace. And by the way, the HMCG2 does not require the relay kit like we have on the HMH7 heat pump product. And so that's a big deal as well, because it does not require a relay kit. And again, as we had mentioned earlier, just conventional 24-volt wiring and function for simplicity of installation. So let's go ahead and take a look at some of those block wiring diagrams right now. And it should be noted that the standard ECM air handler would be an example of that, would be like the JHET air handler, or the legacy AE type of air handler. So this is going to be what we call a standard ECM air handler. So as we kind of take it wire for wire, if we are on an air handler, we're going to have more than likely a heat strip in there. It could be a one-stage or a two-stage heat strip. Today, we are actually featuring a two-stage heat strip. So W2 will go to W2 on the air handler. That's your second stage auxiliary heat. Go ahead.
Lost you there for a second, Joel.
Okay, have you got me back?
Oh, it's me.
Oh, okay. So W2 is going to be your second stage auxiliary heat, and that'll go from your thermostat to the indoor unit. W1 is going to be your first stage auxiliary heat, again, thermostat to the indoor unit. Now the Y terminal is going to go from the thermostat all the way outside, and this is going to be your compressor call. Now please note, on a standard ECM air handler, you may have a yellow wire on the ECM motor, and if it is equipped with that, go ahead and remove that yellow wire, because we're going to be doing some different things with the speed taps on that standard ECM air handler. C is 24-volt common. That's going to go all the way through from the thermostat to the indoor unit to the outdoor product. R is 24-volt hot, and that'll go from the thermostat to the indoor unit only. Now, this is kind of interesting. The HMCG2 does not require 24 volts outside, from the R terminal. So that's a little bit different for wiring, but it's just no big deal. It's just a little bit different. G terminal is our fan call, goes from the thermostat to the indoor unit. Now, on the ECM motor itself, you're going to notice that typically we're going to take W1 for an auxiliary heat call. So let's say, for instance, it's in the wintertime and the outdoor unit is off, but we're utilizing the electric furnace, so to speak, or the ECM air handler with a heat strip in there, or maybe it's a two-stage heat strip. But typically what we're going to do, we're going to select a high-speed tap on the ECM motor, the high-speed tap for a W1 auxiliary heat call. Now, that's very, very typical. Now, the contractor, once he gets out there, if he wants to manipulate and to tweak that airflow, he can certainly do that. But this is just typical that what we see in the field as far as, what speed tap are we going to use for, for what airflow and so on. So that's very, very typical. Then off the motor itself, you're going to have a wire going out to the S1. The S1 is an output from the outdoor unit commanding 100% airflow inside. So we're going to select a speed tap on the ECM motor to give us 100% cooling airflow anytime we have an S1 call or an S1 demand outside. So here's how this works. Basically, the outdoor unit, because it's modulating, when it starts getting into its upper points of modulation, 80, 90, 100% capacity, it's going to generate an S1 signal, which is a 24-volt signal, and it's going to tell that indoor blower to go to 100% airflow. Any questions or comments on that so far? Everyone good? Okay. Yeah. Now watch this, team. We're going to take and we're going to tie into the yellow wire, or the Y terminal going outside, which is our compressor call. And we're going to take that down, and we're going to select a speed tap on the ECM motor to give us 60 to 65% cooling airflow on that initial call. So here's how this works. Here's the logic behind this. Anytime we get a compressor call outside, what's going to happen, we're going to be driving the indoor fan to 60 to 65% airflow. Then as the outdoor unit starts building capacity, or when it starts calling for higher capacity, around 70% capacity or so, it'll generate an S1 output, and it'll call for 100% airflow inside. So this is kind of neat, because we're letting the outdoor unit make intelligent decisions on when it's going to provide 100% capacity or reduced capacity, and we're going to let the outdoor unit make intelligent decisions on the airflow inside. And so combined together, with the intelligence on the board outside and the capability of actually reducing airflow inside, I'll tell you what, we're going to have a very, very comfortable humidity-eaten machine with this combination. Any questions or comments on that? Everybody good?
Yep.
Okay. So as we kind of take a look at the graphic a little bit, one of the things I always like to do is I like to demonstrate what's going to happen, when we energize that S1 circuit. So let me back up one more time. So we see that normal airflow is going to be 60% airflow until the outdoor unit commands 100% airflow by energizing that S1 terminal and then telling the blower motor inside to go to 100% airflow. Okay, so the next thing we're going to talk a little bit about is the TME and the TMY, the standard ECM motor furnaces. And remember, team, these furnaces, even though the TME is a single stage furnace and the TMY is a two-stage heating furnace, they both have the capability of being two-stage cool. So I want to stress that one more time. Even though the TME is a single stage heating furnace, it has a two-stage cooling capability. So it's a really great matchup for this outdoor unit because it does have the capability of that two-stage airflow for the indoor unit. Now, please remember, the TME and the TMY furnaces, again, single-stage and two-stage furnaces. We will not require a relay kit. Again, and let me just make this kind of a wholesale statement. With the HMCG2, we don't need a relay kit on anything. And so that's pretty cool. Everything from our entry-level air handler, and we'll see a little bit later on, all the way up to our variable speed air handler and furnace, we do not require the relay kit. And again, we're going to select go ahead.
So on that, to that point though, we do, this unit does not come with a filter dryer, so it will need to have a filter dryer added to it, correct?
That is correct. So as part of the installation, to your good point, Emily, as part of the installation practice, a filter dryer will have to be installed in the field. Good point. We're also going to want to make sure and select the appropriate thermostat. If we've got a single stage heating or a two-stage heating thermostat, appropriate to the indoor product as far as the heating stages as well. Okay, so let's go ahead and walk on through again, wire for wire. Because this is a single stage heating furnace, we're not going to have a W2 on it, but we'll have a W1 or a W on the furnace. So W1 from the thermostat will go over and hit W on the furnace. Just like before, Y is going to go all the way through, Y to the outdoor unit. C is 24 volt common. That'll also go all the way through as we tie that onto the furnace on the common terminal. R terminal is 24 volt hot, and it does not go outside, just like before. And G is 24 volt fan call. Now we notice that on the furnace, we've got a W1, excuse me, a Y1 and a Y2 terminal. So we're going to utilize those for our cooling speeds now. We're going to take Y2, which is our second stage airflow, 100% cooling airflow, and tie that onto the S1 terminal outside. Then the Y1 terminal on the furnace, which is our first stage airflow, which is going to be, we're going to select 60%, 60 to 65% airflow again on that Y1 call. We're going to tie that to the yellow wire going outside, and that will give us our airflow for single stage whenever we have it calling for that reduced airflow. So let's go ahead and take a look at the TMY. Now, I want to note something. It's going to wire exactly like the TME furnace. The only difference is the TMY furnace has got two different heating terminals, W1, W/W1 and W2. So even though the two, they wire exactly the same, you're going to notice that the terminal identifications are slightly different on the two-stage furnace because now we have a W/W1 and a W2 terminal. But other than that, the Y, the C, the R, everything else wires exactly the same as the previous furnaces. It's just that now we've got the TMY, which is a two-stage heating furnace. So let's take a look at that. So we're going to take W2 to W2 just like we did before. And in this case, because we have a two-stage furnace, we're going to take W1, which is our first stage heat, to the W/W1 terminal. So now it's wired exactly the same, and you can kind of see, team, the theme here is it's pretty simple, straightforward wiring, you know, with the HMCG2, with a conventional thermostat, and lots of capability. As we take a look at the graphic a little bit, we're going to see that we energize that S1 terminal. Again, the S1 is always going to energize and call for second stage cooling airflow. Any questions or comments before we jump into some variable speed products and talk a little bit about airflow considerations as we kind of head towards winding up this little training session this afternoon? Any questions or comments?
So Joel, I know that sometimes there's some limitations on some of the matches, whether it's 80% or 90%. So I think the big comment there is really to make sure you find your AHRI matches before you're selling this unit.
I'm going to tell you what, Emily, that's such a tremendous comment, and you are correct. And that's something I always encourage from a technical support application standpoint, is the fact you want to make sure that, you know, whenever you select a piece of equipment, make sure that you've got the right coil inside. You're going to select the right furnace or the air handler, you know, according to the AHRI matchup. And by the way, sometimes you may not see an exact matchup in our navigator selection tool. And that's okay. You can always go to the AHRI website and see if there's any current matchups for the product. And by the way, you know, our team is continually working on adding matchups all the time. So be sure and go out there to the AHRI website and take a look to see if you've got a matchup before you install it. That's just a really, really good field tip. Thank you. Good
Yeah,
tip.
I know we had a couple that seemed to be missing, but with the TM9Y, some of the ranges were kind of outside of spec, so we weren't able to get that match in yet. So
Okay.
we're still working at trying to get some additional matches.
Well, fantastic. And for all those that view this video, by all means, please get a hold of your champion team. Anytime we can help you with that, we'd be more than happy to help walk you through the AHRI website, give you a little bit of coaching on that. And so, but we definitely want you putting matched equipment in, to Emily's good point. Thank you.
Well, and Joel, on your training channel, we did have a HVAC basics on that covered the AHRI ratings too, so they could go check that video out as well.
Absolutely, absolutely. Great tip. All right, team. Well, let's take a look at taking the HMCG2 with a variable speed air handler and a TMV furnace, or variable speed furnace. And so this time, again, we're going to be discussing that low voltage wiring. We're going to take it wire for wire as we go through there. And as a quick reminder, a conventional 24-volt wiring of a standard one-stage cool, two-stage heating thermostat will be absolutely fine. Now, I want to stress this one more time. You do not need a two-stage cooling thermostat on this product. All you have to have is that single yellow wire going outside. So even though you may have a two-stage heating capable thermostat, you only need one stage of cooling. So it's perfectly fine to use like a two-stage cooling, two-stage heating. But if you have a single stage cooling and a two-stage heating thermostat, that works absolutely fine as well, because remember, we're letting the outdoor unit make intelligent decisions on the second stage of airflow inside, not the thermostat. Okay, so here we go. Here's a low voltage depiction of an air handler, a ABC type of air handler, which is a two-stage, our variable speed capable air handler, two-stage heat, and up to 2 stages of heat or so, depending on what type of heat strip you put in there. You'll also notice it has a Y1 and a Y2 terminal, or Y1 and Y2 wires as well.
Which,
so just
Joel,
like
I think on this could be either the ABC or the new JHVT, correct?
that is correct. And so the ABC and the JHVT, they're going to wire exactly the same, Emily, to your good point.
Okay.
And so just, yeah, absolutely. So W2 will go to W2, W1 to W1, just like we had before. Now remember, team, we just need a single stage cooling thermostat for that Y signal for the compressor call going outside. Common goes all the way through, just like we had before. This is looking very familiar to everyone because it's pretty standard low voltage wiring across most of our product. R is 24-volt hot, and remember, team, it does not go outside. G is our fan call. And we're going to notice that Y2 is going to go up to our S1 input from our, output from the indoor unit, from the outdoor unit to the indoor unit, or output, input to the indoor unit, however you like to think about it. And then, of course, Y1 will go to your yellow wire, which is going to be your 65% airflow. Now, on the TMV furnace family, you're going to notice that it's going to wire exactly the same. It's exactly the same as a variable speed air handler, but please note that the terminals are a little bit different. They're slightly different on the furnace. So we have a W/W1 for our heating terminal, our first stage heating terminal. But other than that, other than the fact that it's labeled a little bit differently and you've got hard screw terminals on the furnace, it wires exactly like our variable speed air handler that we just discussed. And as we discussed before, when we energize that S1 output from the outdoor unit, it's going to send 24 volts into that Y/Y2, which is our second stage cooling command on our variable speed indoor unit. And it's going to drive that fan to 100% cooling airflow. So very, very straightforward. Again, team, we're using the S1 output from the outdoor unit to command second stage airflow, on our indoor product. Any questions or comments on the low voltage wiring and the overview that we've had on how we wire this unit from the outdoor unit to the indoor unit and from the thermostat to the indoor unit? Any questions or comments?
So Joel, I know, just thinking of the variable speed, like this is a really nice option. And I think even when you're talking about the humidity control, especially with the HMCG, I think we even have some nice blower profiles that can go in congruent with this model, right? With the EnviroTrack.
Absolutely. And so to your excellent point and good question, Emily, and comment, basically on the variable speed products team, what we have is we've got some jumpers on the variable speed product that we don't have like on our standard ECM blower motors. And so on the control board on our variable speed product, we can go in there and we can actually not only set up the initial airflow as far as, percentage of airflow and all that kind of stuff, but we can also have what we call some cooling on delay functions, so that every time this thing goes into the cooling mode of operation, it'll ramp the fan from a low speed to a higher speed during that cooling operation to really pull extra moisture out of the structure. So this cooling, this enhanced cooling or humidity control function is available on our variable speed products. So quite frankly, if you really want to tweak the capability of this, inverter drive outdoor unit, I'll tell you, you just can't get better. You can't select a better product indoor than our variable speed product, to your point. Yeah, good comment. Any other good questions or comments? Well, team, we always want to make sure that we remind our customers, and when they're applying this equipment, to please consider, make sure your airflow considerations are in line with what you're doing. And please remember, on every install, you want to confirm proper airflow. And keep in mind as well, the HMCG2 is a modulating system. It's an inverter drive modulating system. And so we have to have our nominal airflow. It's very important that we have the proper airflow. And again, just as a quick reminder, we always want to size our ductwork to provide 400 CFM per ton of cooling capacity. So to give an example, if I have a 3-ton unit, I want to make sure that my ductwork is going to be able to provide 1,200 CFM on that 3-ton unit. And if it's a 2-ton unit, 800 CFM, and so on. Another key consideration we always want to remember as well is velocity across those key components, like ductwork and branch ducts and registers and so on. And so one of the things we always like to do is please look at Manual D. The velocity tables in Manual D specifically address different recommended and maximum velocities in your different duct components. For instance, on your main trunk, recommended is going to be 700 on supply and 600 on return, with a maximum of 900 on supply and a maximum of 700 return velocity. And again, as you kind of walk through, you'll see that the branch runs and the registers and so on have a different velocity recommendation. We're going to always recommend that you follow Manual D, residential duct design recommendations, and look at that velocity when you're designing your ductwork. One thing I always like to make double note of with any type of training that we do is to watch out if you've got a filter grill. If you have a filter grill and the homeowner wants to put in pleated filters, we want to make sure that you have extra return if they've got pleated filters. And please remember, Manual D recommends a maximum velocity across any filter not to exceed 300 feet per minute. So return air becomes very important, especially on a modulating system. And the reason is, if we have reduced airflow on the indoor coil, it's going to make the indoor coil colder. And the outdoor unit, because there's a lot of intelligence on the inverter drive unit outside, it's going to see that as a reduction in capacity, and it's going to start reducing capacity, to match that coil temperature inside. So please remember, we want to have, airflow is important on all pieces of equipment. But if you're dealing with a modulating or inverter drive unit outside, airflow becomes more critical, because the unit outside is monitoring indoor coil temperature by way of the refrigeration circuit. It's looking at outdoor air temperature. It's looking at all these parameters and then making intelligent decisions on what point of modulation it's going to have to meet that requirement or that capacity requirement. So airflow becomes extra important on modulating equipment. Any questions or comments on that?
No, that's a big deal. I know, especially with a lot of emphasis on indoor air quality now. So I definitely appreciate that comment there, Joel.
Absolutely. Well, team, that concludes our HMCG2 training overview for today. Is there any final questions or comments while I go ahead and secure the PowerPoint, and we'll open up our, kind of open the floor up a little bit, and let me turn my camera back on for a minute or two as we take any final questions or comments on our recording or on our training session today. Any final questions or comments?
So Joel, obviously this is a little bit different unit. What makes it stand out to you?
I'll tell you, that's a good question. What I really, really like about this unit is the fact that it's very simple low voltage wiring. It has lots of comfort and lots of features as far as, the capability of giving you a lot of comfort in kind of a mid-tier. And it's also a very compact unit. If you take a look at it, the cabinet sizes outside, they're about half the size. Typically now the 4 and 5 ton model, they're stacked too high, so to speak, or you have two fans. So they're a little higher, but they're thin and they're fairly narrow and stuff like that. So they're very compact. They look nice. They're very, very quiet. And they just provide a lot of comfort, it's a lot of bang for the buck, in my opinion, I guess is what I'm driving at.
Yeah, I know a lot of people say, "Oh, is that a ductless unit?" And that's not necessarily the case.
No, it's not the case. It's just a straight cooling unit. It just kind of has that same look to it, but it's like I said, it's got a lot of capability and a lot of bang for the buck. As a matter of fact, in my new home here in Texas, when I need an outdoor unit or when I decide to upgrade my home, I'm probably going to go to the heat pump model of this unit, which is the HMH7. I like it that much.
That's great, Joel. So I appreciate that. If we do have any questions, it sounds like you're more than willing to answer those, right?
Absolutely, absolutely. Please call me anytime, and be glad to do that.
Very good. Thanks, Joel.
Well, thank you, and thanks for training with us today. Have a great day, everyone.